This is section 3.2, day 2 notes. We're going to find dy dx. We have 3x squared plus 3y squared, but we took the derivative of y, so we're going to represent the derivative of the inside as dy dx. So we have first times the derivative of the second plus the second times the derivative of the first. So let's get everything with the dy dx on the left side here. So we have minus 18x dy dx. And then everything without a dy dx on the other side, which is 18y minus 3x squared. Now let's factor out a dy dx. That's 3y squared minus 18x. And 18y minus 3x squared. And then we'll just divide, and we are done. So when we divide, we can factor a 3 out of the top and a 3 out of the bottom, and then cancel those 3's. Exercise 9 through 12, find dy dx and find the slope of the curve at the indicated point. So we have the power rule, reduce the power by 1. Here we have 2 times y minus 1 to the first power, and that's equal to 0. Oh, I skipped right over the fact that we took the derivative. Now the derivative of the inside is the derivative of y, which is 1, but then dy dx because we took the derivative of y. So we have 2 times y minus 1 dy dx is equal to negative 2x minus 1. So we're going to subtract over the 2 times x minus 1, and then we'll divide by 2 times y minus 1. Now the 2's are going to cancel, so you just end up with x minus 1 over y minus 1. We're going to evaluate that at 3, 4. So 3 minus 1 is 2, so negative 2. 4 minus 1 is 3, negative 2/3. Find where the slope of the curve is defined. We have 3x squared plus 3y squared dy dx, because we took the derivative of y, is equal to first times the derivative of the second plus the second times the derivative of the first. Let's get everything with the dy dx on the left side, and then we'll factor out. So it's 3y squared minus x, and then on the other side we have y minus 3x squared. And then we'll divide. So dy dx is equal to y minus 3x squared over 3y squared minus x. Now the answer, where is the slope defined? We'll say everywhere except when 3y squared minus x is equal to 0. Then if that happens, the denominator is 0 and the slope's not defined. Find the lines that are tangent and normal to the curve at the given point. So first times derivative of the second, but we just took the derivative of 2y, which is 2, so we have dy dx. Plus the second times the derivative of the first, which is 1, and that's equal to first times the derivative of the second, negative 2 sine of 2x. First times the second, plus the second times the derivative of the first, and the derivative of the first is 1, but it's the derivative of y, which is dy dx again. Let's get everything with the dy dx on the left side, and that's 2x cosine of 2y, and then minus cosine of 2x. And then we have negative 2y sine of 2x minus sine of 2y. And let's divide. So dy dx is equal to negative 2y sine of 2x minus sine of 2y over 2x cosine of 2y minus cosine of 2x. And we're going to evaluate this at pi over 4, pi over 2. Sine of 2 times pi over 4, that's sine of pi over 2, that's 1. So we have negative 2 times pi over 2. But then the sine of 2 times pi over 2, that's the sine of pi, that is 0. So minus 0 over cosine of 2 times pi over 2. Cosine of pi is negative 1, so negative 2 times pi over 4, because x is pi over 4. Cosine of 2 times pi over 4, that's cosine of pi over 2, that's 0. So those cancel out, the negatives cancel out, and we have pi over 2 divided by pi over 4, but we can put times 4 over pi. So the slope is 2. So letter A, we got y minus pi over 2 equals 2 times x minus pi over 4, and then b, the normal line, is y minus pi over 2 equals negative 1/2 times x minus pi over 4. Exercise 27 through 30, use implicit differentiation to find dy dx and then the second derivative. So let's do the first derivative. We have 2y dy dx is equal to 2x plus 2. So let's divide by 2y. That's x plus 1 over y. Because we can factor out the 2 on top, cross it out with the 1 on the bottom, and that's what we end up with. So the second derivative is bottom times derivative of the top minus the top times the derivative of the bottom, which is 1, but we just took the derivative of y, so it's dy dx, over y squared. And that's equal to y minus x plus 1, but then times x plus 1 over y, because we know what dy dx is. It's x plus 1 over y, so that's what we plug in for dy dx. Now that's over y squared. Let's multiply everything times y so that these are going to cancel out. That's going to be y squared minus x plus 1 squared over y to the third. We multiplied everything times y. Well, that's y squared minus x squared plus 2x plus 1 over y to the third. And then this is y squared. We get y squared minus y squared over y to the third. So in the end here is 0. Now, not all of these problems will have this many substitutions that we can put in, but I just want you to be aware that you might have to look back and see if we can do any kind of replacements. Exercise 9 through 12, find dy dx and find the slope of the curve at the indicated point. We have 2x plus 2y dy dx is equal to 0. So 2y dy dx is equal to negative 2x. And then we can divide by 2y. So negative x over y. We're going to evaluate this at 0, 3. So 0, negative 0 over 3 is 0. Well, that's really, this is a circle with a radius of 3. There's the circle, and they're saying, well, what's the slope of the tangent line up here at 0, 3? Well, it's 0. Find the lines that are tangent normal to the curve at the given point. We have first times derivative of the second, dy dx, plus the second times the derivative of the first is equal to 0. We have 2x squared y dy dx is equal to negative 2xy squared, and then we'll divide. So dy dx is negative 2xy squared over 2x squared y. We're going to evaluate that at negative 1, 3. So see on the top we have negative 2 times negative 1, that's 2, times 9 is 18. In the denominator we got that's squared. 2 times 1 is 2, times 3 is 6. So the slope is 3a, y minus 3 is equal to 3 times x plus 1, and b, y minus 3, is negative 1/3 times x plus 1. There's the normal line. The velocity of a falling body is that, feet per second. At the instant t, the body has fallen s feet from its starting position. Show that the body's acceleration is 32 feet per second squared. Well, the derivative of velocity is acceleration. That's going to be 4 times s minus t to the negative 1/2. And then the derivative of 1 is 0. But I need to multiply times the derivative of the inside. Well, s is position. The derivative of position is velocity. And then the variable is minus t, so that's minus 1. Well, that's 4 over the square root of s minus t times the velocity is 8 square root of s minus t plus 1, and then minus 1. So that minus 1 is right there. So then the 1 and minus 1 cancel. We have 32 square root of s minus t over square root of s minus t. That is 32. Exercise 27 to 30, use implicit differentiation to find the first and second derivatives. So we have the first derivative, 2y dy dx plus 2 dy dx is equal to 2. Let's factor out the dy dx, and that's 2y plus 2 is equal to 2, and then divide. So dy dx is 1 over y plus 1, because we can factor out the 2 in the denominator and then cancel with the 2 on top. Well, this is equal to y plus 1 to the negative 1, so I'm not going to use the quotient rule on this, not for the second derivative. I'll just use the power rule. Y plus 1 to the negative 2, but now times the derivative of the inside is 1, but I just took the derivative of y, so we have dy dx. That's negative 1 over y plus 1 squared, but dy dx is 1 over y plus 1. So negative 1 over y plus 1 to the third power. Find the lines that are tangent and normal to the curve at the given point. Well, dy dx here is equal to, oh boy, we're going to go 2 cosine of pi x minus y, but then times the derivative of the inside is pi minus 1, but then times dy dx. Should I put that on the outside? I don't think I should put that on the outside. I think I should put that on the inside, actually. So times pi minus 1 dy dx. That's how I need it. So dy dx is equal to, we got 2 pi cosine of pi x minus y. So I'm distributing this through. And then minus 2 cosine of pi x minus y dy dx. Now I'm going to add that over. So we have dy dx plus 2 cosine of pi x minus y dy dx is equal to 2 pi cosine of pi x minus y. And then factor out the dy dx. And that's 1 plus 2 cosine of pi x minus y. And that's equal to 2 pi cosine of pi x minus y. So now we divide. Dy dx is equal to 2 pi cosine of pi x minus y over 1 plus 2 cosine of pi x minus y. Now we have the point 1, 0. All right, 1, 0. So we have 2 pi cosine, well, we're evaluating this at 1, 0. So 2 pi cosine, that's going to be just cosine of pi. I'll write that. Over 1 plus 2 cosine of, 1 in for x is pi minus 0. So that's pi. Cosine of pi is negative 1. So negative 2 pi over 1 minus 2, right? Because cosine of pi is negative 1. That's negative 1. So, 2 pi. That is the slope. So A, y minus 0 equals 2 pi times x minus 1. And B, y minus 0, 0 is equal to negative 1 over 2 pi, x minus 1. And I got to look at the instructions. Do they want tangent and normal? Yep, got it. The line that is normal to the curve at 1, 1 intersects a curve at what other point? Let's get the equation of the normal. We have 2x plus first times derivative of the second plus the second times the derivative of the first minus 6y dy dx is equal to 0. So let's go dy dx times 2x minus 6y is equal to negative 2x minus 2y. And then we'll divide. Dy dx is equal to negative 2x minus 2y over 2x minus 6y. And we're evaluating this at 1, 1. So negative 2 minus 2 over 2 minus 6. So negative 4 over negative 4, we get 1. So the normal is y minus 1 is equal to negative 1 times x minus 1. That's the normal. And now let's get y by itself. So y equals negative x, negative x plus 1 plus 2. Now that's the normal line. And we're looking for where this curve and this line intersect each other. And we're going to use substitution to do that. So we're going to put this in for the y's up here. We got x squared plus 2x times negative x plus 2 minus 3 times negative x plus 2 squared is equal to 0. So we got some algebra to do. X squared minus 2x squared plus 4x minus 3 times x squared minus 4x plus 4. All right, what do we got here? X squared minus x squared, negative x squared plus 4x minus 3x squared plus 12x, and then minus 12 is equal to 0. So we got negative 4x squared plus 16x minus 12 is equal to 0. Let's take a negative 4 out. So x squared minus 4x plus 3 is equal to 0. And that's negative 4 times x minus 3 and x minus 1 is equal to 0. Well, now the other one we were looking for is 3 because we already got the 1. We already got the value, the point when x is 1. We just need the point when x is 3. So we're going to plug that into this one because they're shared points. So this should be on the other curve also. So negative 3 plus 2 is negative 1. So it's point 3, negative 1 is the other point. And we've already done that one, and I think we're pretty good to go here.